Hey guys, today we're going to talk about arrays. We're in chapter 6. Go ahead and read chapter 6. Presumably by the time you're taking this course, you've already taken another programming course, C, C++, Java, Python, something like that, and you've already used arrays. I'm going to make that assumption. If you need to, go and Google some YouTube videos about arrays, read the chapter carefully. I'm not going to focus too long on all the basics, but we're going to show how to create arrays, how to sort arrays, that sort of thing. How to copy arrays. So, I'm not going to go step by step through the PowerPoint because you can do that yourself. Go ahead and create a project. So, what is an array? An array is a sequence of values. The values, which I'm going to try to call elements from now on, all need to be of the same type. You know, they all need to be integers or doubles or strings or, you know, some class. However, with inheritance, you can do some tricks, and well, they're not even really tricks. But, you know, you could store things that seem to be of different types as long as they're all inherited from the same type. You could create an array of object references, and then if you had some way of testing to see what kind of object you had, well, that's all for a later lecture. So go ahead, create your project. I'm going to assume that you have mine now. The way you create an array is something like this. We're going to create an empty array first. Int, stop it, auto fill in IntelliSense. Int, let's zoom in a little bit. Nums is equal to new int 5. Alright, now we have space for 5 values, 5 ints. If we printed them out right now, they would all be zeros. The default values we can allocate a new array are zeros or falses or nulls, depending on whether, you know, what you're allocating. So we know that we have 5 integers equal to 0 at this point. I'm going to create 5 elements. I'm just going to do A, B, C, and D. A is equal to 100. B is equal to 200. C is equal to 300. D is equal to 1 for no reason whatsoever. Maybe we're going to sort it and see what happens. And E is equal to 2. Now, we have 5 ints. We don't have them in our array yet, right? So, let's put a couple of those values into our array. The name of our array is nums. And here's how you declare an array. You give the type, then you give the square braces, nothing between the square braces. So after the type, the square brackets, then the variable name. There's a couple different things that can follow here. You don't have to allocate it like that. You could just put a semicolon there and allocate it later. Or you could use an initializer list, as we've talked about. Anyways, let's start doing this. Nums at position 0 is equal to A. Oh, come on, IntelliSense. Nums at position 1 is equal to B. Now I'm tempted to copy and paste or to not type so much. Nums at position 2 is equal to C. You get the idea. Nums at position 3 is equal to D. Nums at position 4 is equal to E. Alright, now if we print them out, we're going to see 5 values, and they're going to be in order. 100, 200, 300, 1, and 2. So let's say we wanted to print those values. I'm just going to use a console.writeLine statement. Console.writeLine, and I'm going to use 5 placeholders because we have 5 values. 0, 1, 2, 3, and 4. And this is the last time I'm going to use this fashion of printing the arrays. From now on, I'm going to use loops or some method that will convert the array to a string. All right, but we have 5 placeholders. We need to fill them in. So first placeholder gets filled in with nums 0, and then nums 1, comma, nums 2, comma, nums index value 2. The thing between the braces is called the index. The textbook also calls it a subscript. A lot of other textbooks don't call it a subscript. I actually like that nomenclature. So we've got nums 0, nums 1, nums subscript 2, nums subscript 3, and nums subscript 4. And then my closing brace for my right line statement. Do you have to break it up into 2 lines like that? Of course not. I just do that to get it all on the screen when I have a large font. All right, I'm going to run it. Rebuild my solution. Start without debugging because I haven't added a read key to the bottom. And here we go. It ran it. 100, 200, 300, 1, and 2. Very good. So a couple of things to note. We have 5 spots. We have 5 little boxes to store numbers in. They are indexed by the values 0 through 4. Because if you count them off on your fingers, 0 through 4 is 5 values, as you can see clearly here. And that zero-based indexing ought to be pretty familiar just from our right line statement, where the first argument we're printing is given a placeholder value of 0, and then 1, and then 2, and then a 3, and a 4. So if we wanted to change this 300 here to a 500, for whatever purposes, here's how I might think I could change it, and it would be absolutely wrong. C is equal to 500. All right, I'm going to run it again. Debug, start without debugging. And then when I run it, lo and behold, it still says 100, 200, 300. Why? Because the array is storing copies of the values. It copied in 100, 200, 300, 1, and 2 all the way through here. So just because we changed the original, we didn't change the copy. You know, you Xeroxed off 5 pages of papers, and then you wrote 500 on the middle page of the original. It didn't change the photocopy. So that was a waste. Instead, we could do this. Nums subscript 2 is equal to 1,000. Semicolon. Then we run it. And since I ran it without start without debugging, okay, I'm going to go ahead and add my console.read key at the bottom there. Here we go. 100, 200, 1001, and 2. So it actually did work. All right, that's one way of getting data into an array. What if the array was 100 elements long? What if we changed the length of the array to 10? What if we went up here and allocated 10 rather than 5? Well, this would only create 5 values, right? Not 10. So we would have 5 wasted, 5 left over. Do I really want to allocate an array, a series of variables like that, and then copy them into them like that? Not really.
I don't get it, but I can check the web.
So what I want to do, perhaps, let's just copy those values in directly. I'm going to change that 100, 200, 300, 1, and 2 so that it doesn't require those variables. So I'm going to delete that A there, and it's going to say nums subscript 0 is equal to 100. Num subscript 1 is equal to 200. Num subscript 2 is equal to 300. Num subscript 3 is equal to 1. And num subscript 4 is equal to 2. Now these original variables are no longer necessary. See that? I just assigned the values directly into the array. If I continue playing with these, that's how I'm going to do it from now on, most likely. I'm going to run it again just to make sure that I get the output that I'm expecting. Change the font size a little bit, make it more legible to us. All right, there we go. All right, print it out 100, 200, 1,000, 1 and 2. Remember, we changed that value to 1,000, the middle one, right there, so that even though we got 100, 200, 300. All right, what if we didn't know how many data elements? What if we changed, I mean, we did already change this to 10, but we've only got 5 pieces of data in here. What if we changed it to 3? What if we said, okay, we only want 3 numbers? We've got a problem here. We're trying to store 5 values into an array that only supports 3. It's like you're trying to move 5 families into an apartment complex with only 3 apartments. So we're going to get an error. It says unhandled exception, index out of range. So since this has been changed to be an array size of 3, we can only access elements 0, 1, and 2. So the official way to say that is the index value of the array, or the index can equal 0 to n, where n is equal to length of the array minus 1. So this is not a great way to handle data entry, actually, of course. You wouldn't want to just write 5 input statements and store the 5 different values in it. You'd probably want to loop. What do I mean by looping? You know, a for loop, counting from 0 to 4, or 0 to the length of the array minus 1. Same goes for printing. Printing like this is just kind of lame, because what if we later change it to 3 or 10 or whatever? We don't want to have to go and change this right line. We want to print our array out with a loop. Let's go for it. We're going to write a loop. We're going to count our index counter, I. I'm going to start it at 0. Go while I is less than 5, which is really lame because, again, I'm hard coding a value here. I should be using the length of the array. So I'm going to be changing that 5 in just a moment. But anyways, I is equal to 0, I is less than 5, I plus plus. Open brace, close brace, and inside those two things I'm going to say console dot write line nums at index placeholder 0 equals placeholder 1 end quote, comma, and on the next line I'm going to put the index counter itself and then the nums subscript I, then a terminating semicolon, of course, which it's complaining about because I forgot to put my trailing parentheses. I have an opening parentheses there, I need to close one there. Alright, let's go. We run it. Our original print statement, and I'll bring the code back up. You may not have gotten a chance to type it all in. 100, 200, 1000, 1 and 2 at index positions 0, 1, 2, 3, and 4. Alrighty, so that's creating an array to print, that's creating a loop that will print out the values. A lot of times when you're dealing with arrays, you'll be using loops either for data entry, for data processing, or for output. And as I mentioned, using 5 there is really lame because if this array was changed to 5,000, we'd have to come down here and change that to 5,000. You don't want to go through your code and change it everywhere. And the way that the C programmers might have done it is they might have declared a constant with the length of the array. But we can query the array and find out its length. And that's because in C# everything is an object, even arrays, which is not true in C++. It is true in Java, except for primitive data types like ints and floats and doubles. But even in C#, even those things are objects. So what does that mean? Instead of I is less than 5, change that to I is less than nums subscript. No, what am I doing? I don't want a subscript there. Nums dot length. And length is not a function. It's a property. So we didn't put parentheses after it. All right, I could run it again, but I know it's going to work. All right, so let's do some data entry using an array. Let's not reuse nums. I'm getting kind of tired of that array. Let's declare an array of names for whatever purpose. I have to declare my array first. String, square brackets, then the array name, which I'm going to call names, is equal to new string. I'm going to give it, let's just do 4 names. Same kind of for loop, except instead we're going to write a message and then ask the user for the name and then store it. So for int I is equal to 0, I tend to reuse I as my for loop counter. I is less than names.length, semicolon. I plus plus, close parentheses, open brace, close brace if you don't already have one there. Let's tell them what kind of information we want. Console.write, parentheses, please enter name, placeholder 0, end curly brace, space or colon, and then a quote, then a close parentheses and a semicolon. So my string says, quote, please enter name, space, curly brace, 0, end curly brace, colon, then that space. Except I haven't filled in my placeholder. So between the quotes and the parentheses, put comma I. So to say, please enter name, count it down. 1, 2, 3, 4. It's actually going to start counting as 0, which is going to be annoying to the user. They don't want to think about name number 0, name number 1, and name number 2. They actually want to see names 1, 2, 3, 4, and 5. But I'll fix that in a minute. I'm just going to leave that there. Now we need to get our input. I'm going to read it into a temporary variable. It's called s. String s is equal to console dot readline. Then let's store it into the array. Names at position I is equal to s. Good enough? We're going to need to print those out. All right, now I want to write my names out. Instead of using a for loop, we've already typed this syntax twice, so you're getting pretty used to it. We're going to use a for each loop. A for each loop you cannot use for input, but you can certainly use it for output. You Java users have already seen the for each syntax. You Python users have already seen the for each syntax. It's a little bit different in this one. Just take note. It's not for, it's for each, and then parentheses. String S in names. On the next line, okay. For each, parentheses, string S in names, close parentheses, console.write. I'm just going to write them out all on the same line. So I'm not going to use write line. So I'm going to write S out plus a space. And then underneath that, I'm going to write line. Just to get it to go to the next line. And maybe I'll add a console.writeLine above it saying what we're about to see. Console.writeLine. Names you entered. All right, now run it. Here's what I get. Please enter name 0. We're going to change that to 1, right? Lisa. Please enter name in 1, Bob. Name 2, Sally. Name 3, Carl. The names you entered, Lisa, Bob, Sally, Carl. We might want to sort those names. We might not, but we might want to sort those names. Let's see if there's a way to sort them. So let's sort the data. There's a class called array with useful methods. Array.sort, parentheses, names. That's all it takes to sort our arrays. In other languages, you may be used to the idea that you would then have to store that result in another array variable. That's Python. We don't care here. C# goes ahead and sorts it right there for us. So we're good enough to go. Why don't we then print them out again? I'm going to use a for each loop again, but it's going to be less groovy because we're not going to write them all on the same line. We're going to, So for each. Some people like to do this. String name without an S in names in parentheses. Open brace, close brace if it didn't already add it. All right, why do they like to do this? Because they name their arrays with plurals, and then they can name their counters, not their counters, but their value iterator. Singular. That's a great syntax, but when I'm typing in code examples, I don't want to get it easy to confuse where people might confuse when I say name as opposed to names, or they type in S when they're not supposed to, or they leave off the S. So I'm going to go back to my temporary variables, string S in names. Complaining about this because I've already declared S up here. Interesting. No, it's not complaining about it. Let's just run with it. Console.writeLine S. Good enough, huh? But above it, let's say what we're doing. Console.writeLine names after sorting. All right, we're going to run it again, and we're going to have to type 4 names in again. Gets to be kind of tedious when we're testing these programs over and over, and we have to type in a series of values. Yeah. All right, so run. Here's what it's asking me for. Name 0, Lars. Name 1, Kirk. Name 2. Kirk. Then how about James? And then the last name going to be Cliff. All right, Lars, Kirk, James, and Cliff. All right, the names we entered were Lars, Kirk, James, and Cliff. The names after sorting, Cliff, James, Kirk, and Lars. So it did, in fact, sort them alphabetically. Let's say we wanted to find out if one of these, we wanted to do a search. We could search this manually with a for loop. Maybe we'll do that slightly later. But there's a binary search method where you pass the array in and then you specify the value you're searching for, and it tells you either the index value of where it was found or that it wasn't found. So this may be about the last thing we do to this one, is to search the array. Then we'll end the lecture. We'll do another one very soon on Monday. I think this will be enough for now. So if we look at the PowerPoint, there's a binary search method. A binary search is a specific form of search. I may lecture a little bit about that, but what the idea is say somebody tells you to pick a number between 1 and 100, and they're thinking of the number, 63. If you're going to do it with the most efficient algorithm, you're going to go 50, right? That's between 1 and 100. They're going to say, nope, the number's larger. Hopefully they'll give you that clue. So then you think to yourself, okay, what's between 50 and 100? Well, it's 75. So you guess 75. And they say, nope, I wanted 63. You better guess again. So then you know that the number is somewhere between 51 and 62. That's a range of 11, huh? But anyways, let's pick a number that's somewhere between 51 and 62. About halfway through. That might be 65 or 66. Let's say it's 66. Running this off the top of my head. They say, nope, that's still too large. And you go, okay, I know it's between 51, 60, yeah. I know that. You keep guessing, half, 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 until you zero in on it. That's the binary search method. If you have a sorted list of objects, you can do a binary search, but it has to be sorted. Don't use binary search if your array holds duplicate values and you want to find them all. Otherwise, it'll just find one of them. And if your items are not arranged in ascending order, then you can't use a binary search. But our data is now in ascending order, and if we interrupt unique data, then we don't have any duplicate values. So let's add a binary search command to it. Here's the syntax. Array.binary search, followed by the array name, followed by the value that we're searching for. So let's do that. Let's just search it for the value Sam. If there's a Sam in it, we'll find out. If there's not a Sam in it, we won't. What binary search returns is the index position where Sam is in our array. And if it doesn't find it, it returns a negative number. So let's do that. Let's do console.writeLine searching for Sam. And let's do it. Int, what am I going to call it? SI for Sam position. IF, or index found. That looks like the word if. That's a totally bad choice. I'm going to call it result. Int result is equal to array dot binary search, parentheses, then the array name, which is names, and the value we're looking for, which is Sam. In real life, would you hard code a value like that? Nah. Now we're going to check. If we got a result of 0 or greater, we know we did find it. If we didn't, then we didn't find it. So let's check. Let's rule out the error condition first. If result is less than 0, we're going to print an error message. Console.WriteLine. Sam not found in names. Close brace. Else. Open brace. Console.WriteLine. Sam found at index placeholder 0, end quote, comma, and the name of our index in this case was result. Close brace. So let's run it. Enter name 0. Kirk, Lars, Cliff, James. The names is entered: Kirk, Lars, Cliff, James. Names after sorting: Cliff, James, Kirk, Lars. We're searching for Sam. Sam not found in names. All right, we tested one path, but you always want to test both paths through your program. Programmers usually test to make sure their code works, not to see if they can make it fail. And then you give it to the customer and they find a way to make it fail. So we're going to test for something that's not in the list. No, wait. We already tested for something that was not in the list. Now we're going to test it for something that is in the list. So let's enter Sam as one of our names. Bob, Sam, Joe, Jack. The names are entered. After we sort them, they're Bob, Jack, Joe, and Sam. Searching for Sam. Sam not found in names because I wanted an uppercase Sam. Well, well, well. Alrighty. I'm going to test it one more time. Enter an uppercase Sam. Please enter name 0. Alrighty. I never did fix that to say 1, 2, 3, 4. I just add a 1 to it as I'm printing it out in that right line that was up there. Okay, Bob with a capital B, Sam with a capital S, Sally with a capital S, and, you know, Dad. Alrighty. There we go. Sam was found. Sam was found at index position 3. And that's true, because that's 0, 1, 2, and 3 after we sorted it. All right, that's about enough for now. What we're going to do on the next lecture is talk about copying arrays and a few more things about arrays. So, I'll see you soon.